uh, we are about to start the class, and besides uploading your homework, I need to know that which one is going to do the presentation today for each group. Okay? And very well. Very well.
Yes.
Are you able to do the presentation today? You are not even in any group. I didn't see you. You belong to any group. Would you please do the presentation today?
I'm sorry, I can't understand.
I didn't hear you, please.
Hello?
I didn't hear you.
Oh my God. Am I audible now?
Louder?
Can you hear me now?
Excuse me, I didn't hear you, please.
Oh. How about now?
So you're going to do the presentation today, right? Excuse me.
Hello, Prof.
I cannot hear you. Go hear her, what she said. Oh, very well. Are you
Hello?
sorry?
Yes, hello.
Can you hear me, Manuel?
Yes, I can hear you.
You cannot hear me.
Hello?
Can you hear me right now?
Yes, I can hear you, but I'm not sure if you can hear me.
Huh?
I can hear you, but I'm not sure if you can hear me. But I can hear you right now.
Oh. Oh. So are you able to do the presentation? Maybe not.
I'm sorry.
I really didn't hear you very clearly. How about you? Huh? What should I do?
I'm sorry. I'm sorry. I don't know why I'm not audible.
Oh, turn on this one louder. Okay. Okay, then we'll please say something again. I now I'm testing my microphone.
Hello, Prof. Can you hear me now?
Oh yes, I can hear you right now. Thank you very much.
I Yes,
Thank you.
I'm just typing on the chat box because
Uh,
I'm not sure if you can
okay,
hear me
uh,
earlier.
just a second, okay? I need to arrange the presenter today. So if you do the presentation, I think you will be the second one, okay? The first one will be the math, okay? Then very well, okay? Then please wait for a second, then I'll see the other groups, the presenter first, all right? So let me check with your homework. 3 more. All right. Let's see whether who is going to do the presentation today. So the first one will be Max. The second one will be Marywell. Then let me see. Harry. Sure. Okay. Then who is the presenter? Okay, please speak. Okay. So, you are the presenter today. Rachel, which one? I'm a presenter today.
Oh, we have to do it. Okay.
Sachin, so you're going to be a presenter today?
Yeah, I can.
Okay, sure.
You want to be Rachel?
Stephen. Oh, where is sure.
Sasa.
Sure. Okay, one is from India, the other one is from France. Huh? It's you? Okay. Then Jackie. Okay, who is going to be the presenter?
Rachel, you feel the urge to do it, or you were okay with me doing it? What? Oh, dear Rachel, your voice is not that loud. You want to do it, or I can do it? You want? Yeah, it's simple.
Stephanie,
Maybe it's
who's going to be the presenter today?
You are good. You want to do it?
And Katja, you, and who is going to be the presenter today? Katja. Okay, I think all the presenters are set it, okay? Let me see. Who didn't turn in the homework? Who didn't turn it? I'm going to check it later on. Sachin, did it turn it? Why? You're doing it right now. Huh? Okay, you're doing it right now. So we can do it 5 or 10 o'clock. Okay. All right? Then I think let me just announce a little bit, okay? Max will be the first one, and Manuel will be the second one. And there's one more group. Daisy. Okay, who is going to be the presenter? Okay, is Daisy. So Daisy will be the third one. Third. Okay, then Junkai will be the fourth one. Then Rachel, fifth, and Vicky, sixth, and Calvin, seventh. Then Letitia. Huh? Letitia. Okay, right. Then I think let's start it to do the presentation, okay? So, if you do the presentation, okay, let me help you. So the first one is, the first one will be the math, right? So what I'm going to do is download your homework here, okay? Then let's put it in the desk. All right? So math, you can turn it on and do the presentation of yours. Okay, then please come up front. Okay, come here. By the way, when speaker or the presenter is doing the presentation, everybody should be kept very quiet, because in this room, all the microphone will have all the voice from the classroom, okay? All right, not just the microphone.
But you can ask questions if you want.
If they want to ask questions, I mean, yeah, sure. If you want to ask questions, then I will give you the microphone. You should use the microphone to ask questions, okay? Or I may ask questions too, okay? All right. So, please do.
Yeah,
Make it loud, bigger, larger, make it larger. Like around 120 or 130. Now my eyesight is not very good. 120. Oh. Yeah, from here. You make it larger. Something like this one.
Okay.
Yeah, please make it larger,
Okay.
right?
Yeah. Good morning, Prof, and then good morning, my fellow classmates. I simplified
You
it.
have to use the microphone.
I think you can hear.
No. You have to use the, otherwise never will cannot hear you.
All right. So,
Because we're all in the teams.
all right. So, I simplified the assignment by just answering the question, leaving the questions away, just display the answers. So what I did is, the first question asked us to take a look at equation 1.8 and to think if our estimated coefficient will support our expectation. So what I did is, I said, first of all, before we try to explain equation 1.8, let's take a look at equation 1.7. Because equation 1.7 is the equation that gives us equation 1.8. They just give it to us in an econometrics format. So I tried to explain the variables first and their interpretation. So what I did is rating, which is equation 1.7, which is here. This is our dependent variable. And then we have our constant here, and these are our independent variable, and this is the error term here. So if we don't have this error term here, following the rule of math or rule of thumb, these two positive things will give us a positive feedback here. So knowing that, I then try to explain the variables here, which is rating as y is our response variable. Then is rating a professor who is very easy, and then I said is x1 is the first predictor variable or first predicted variable. Then path as b2, which is b2 here, is the second predicted variable. And EI is a residual error, which is an unmeasured variable. The reason why we cannot measure this error time is, for instance, if they ask you to measure the satisfaction or utility satisfaction, you cannot measure utility, or you cannot measure if you eat an apple, the taste you get from eating that apple, you cannot measure that taste. So that's the error time that we cannot measure. So from that model, I then try to explain the parameters in the model above, which is BO is the y-intercept, and then B1 is the first regression coefficient, and B2 is the second regression coefficient. So the whole question was to ask us whether our expected estimated coefficient will be our expected output. So here we look at it, this is constant and this is positive and this one is also positive. So in order to answer the question, I said I strongly believe the estimated coefficient will support our expectation because our beta constant and intercept is positive and our predictors are also positive. So I use e-views in order to prove this, whether to see whether our expectation will be the same or not. So using e-views, we can see that it turns out to be the same. So if we are to rate a professor, rating a professor, if we hold part constant, we can see that this is a positive relationship, holding every other thing constant. And likewise, if we hold these constant, and this will be a positive relationship, like they explain, they give us in the question. So I went ahead and I said, the above, oh, this should be table. The above table gives us our equation, 1.8. We can agree that the output in this line with our expected estimated coefficient, our estimated coefficient, given that one scale increase in ease will increase our rating by this percent, while holding hot constant. Likewise, if we hold hot constant and increase in hot, one scale will increase our rating by this percent for the professor. We can conclude that the relationship between independent variable rating and two dependent variables is and hot are what positive correlation. So question C asks us if these two variables used is enough to judge a professor, to rate a professor. So I said my solution to that is I think we should find another variable, which is to quantify or to test the education level or academic level of the profession. So what I did is I generate another variable. How I did that is I multiplied educational level here. I multiply ease by hot to judge the professor educational level. So after doing that, I have a new output. So this is the new equation that we have if we add another one more variable, which is educational level here. All other things remain the same. So we can see that our ease and hot have changed to negative, which means our educational level best explained when we are to rate our professors instead of ease and hot. So I prefer educational level of the professor to be used to explain when we are rating a professor, let's say performance or something, instead of using ease and hot. That's it. The above table shows the output of our new regression. We can see that our two predictors have changed with a negative relationship. Before they give us a positive relationship, but now it is a negative relationship. We can conclude that variable A, which is education, best explain the rating than the two variables above. Yeah.
Okay, this is all I have.
Yes.
Okay, all right. Any questions from students? Perfect. Huh? Well, let me say something about it, okay? Would you please move down? Let me see.
Up.
Yeah. Okay, all right. These two variables, one is and hot, okay? Then what do you expect? The sign of the is or hot? What's the relationship? And rating. How do you think? You all think it's positive relationship from your expectation. So in other words, the meaning, the definition of the is what? Is the workloading, right? If workloading is easier, then the students rate the performance of pressure is going to be higher. Right? So it means that if this professor give you easy homework, then the performance of the teacher will be higher. Okay? Then the second one is hot, means the more, the appearance of the professor is more, attractive, is more attractive than the performance of the teaching. The rating is higher. Is that right? Oh, okay. All the students related to this. So you agree or you respect. You have the positive relationship to these two variables. All right. Then I think there's a new things from math, okay, which is using a new variable in his homework. So would you please, he's using education variables, which using the original is and hot, okay, multiply them together, okay. So in other words, we do have the similar similar information. All the variables are information, right? So math using a new information, which is the interaction of these two variables. And we have to understand that since this is the multiplication of these two variables, then we do provide some old information into a new information, which is the interaction between is and hot. Okay, then, okay, this is the result. It turned out to be this result. Okay, then I think this is raise the other problems or questions, okay, which is going to be covered in the next semester instead of this semester. Okay, we will have another class, okay, related to this course, okay, which is in next semester. All right, so I'm not going to explain it now, but Max, I'm going to tell you that this is going to create another problem.
Yes,
Yeah, okay, I think you know it, right?
I just limit to the test whether
Right.
the sign to change or not.
Yes, yes, okay. So this is very good example which we can use next semester for this course, for another course, okay? Just bring up another very good and typical questions in econometrics, in regression analysis. But I'm not going to cover that this semester, all right? Okay, so thank you very much. All right. Okay, now, excuse me. Okay, let's turn to the teams. Okay, hello, Manuel.
Hi, hello, Prof. Should I just share my screen?
Can you share, you know how to do that?
Yes.
Okay, from Teams, did you see this, can you see this function called share screen?
Yes, I'm sharing it right now. Can you see my screen?
Okay, let me see. Oh, yes, we do. Yes, we do see. Okay, would you make it a little bit larger? Using make the Word file, the print is larger. Enlarge it from 100% to 130.
All right.
Make it from lower right-hand side.
Is it the
The
view?
original one is 100%. Make it like 130%. Make it larger.
Not moving though.
Lower right hand side
Like, should I?
is what I usually do.
130%.
Yeah, okay,
Is it
okay.
okay now?
Yeah, that would be
All
fine.
right.
Make
All
it
right.
all
All right.
space.
Good morning, everyone.
Yeah,
Hope to see you
okay.
all next week. Okay, so for my presentation, it's a bit more simple than the previous presentation. So for the exercise 8, letter A, we have to take a look into the equation. Given that we're looking for the teaching rating of the professors, considering that um, our uh, our independent variables are the ease of the workload or the quizzes grading that the professor gives, and the hot, or which is the measure of the attractiveness of the professor. So the equation that we'll use is rating I is equal to 3.23 plus 0.01 ease of I plus 0.59 hot I. So there. For the first question, do the estimated coefficient support the expectation? Looking at it, both have positive coefficients, so we would initially see it as it supports the expectation. However, taking into consideration that the maximum value for is 1 and the maximum value for hot is 5, I think that they're not directly comparable. And then if we test the equation, we run it through eViews. We get this data wherein the regression coefficient for hot is 0.59, and then for ease it's 0.006 or 0.01, and then our intercept, or the constant value of the coefficient is 3.23. Given this figure, we can assume that for every um, increase in one scale of hot, there is a 0.59 increase in the estimated rating for the professor, whereas for one scale increasing is there is a 0.06 increase for the rating of the professor. Okay, now letter C. As these are two independent variables, I haven't done what the previous presenter did, that he included another independent variable in the e-views. But just to answer the question, there are other variables that can be considered for the teaching rating. Could be like class attendance, mastery level on the subject matter, and the number of students with passing grade, but I haven't run it through e-views. And then suppose that we are gonna add them to the present independent variables such as ease and hot, I expect that the coefficient of hot would slightly decrease in size, whereas the coefficient of ease might increase. That's it. Thank you.
Okay, any questions from students? Manuel, I need your screen too. Without your screen, I cannot see
Sorry.
the result.
I'm sorry.
Would you please
I'll just reshare
share your
it.
screen again?
I'm sorry.
All right. How do I get this out of my screen? Huh? This is- Oh, okay. All right. Okay, Gabriel, would you
Yes.
please pass down, roll down your, all right, put this here, okay? Uh, you're suggesting, you're suggesting other variables such as, class attendance, means students, uh, attendance, right? And master level on the subject matter, what does this mean?
The knowledge of the mastery level of the professor or the teacher on the subject being taught.
So do you mean that whether this is a master class or master level on the subject matter?
Master, yes,
Is
I
the,
can,
the
I,
content,
I, sorry.
I mean, the course content,
Yes, mastery level on the content of the course being taught. Or the
and,
knowledge. Not sure if that's the right term.
and the number of students with passing grade means,
Yes.
uh, the definition of REs is the homework, right? And the definition here for you, number of students with passing grade means is whether it's easy to pass it or not. Right?
Yes.
This is what you mean. Okay,
Yes,
so
because yes.
it means that
Essentially if you're like a good teacher, I feel like majority of the class should at least have the passing grade.
even a good teacher always with a passing grade is high or something.
That's what I'm assuming.
All right. So this one is really you know force our thinking. Okay. What's the relationship with the x variables they already provided, as well as some other variables which you think have more relationship with the y variables. So, there's no there is no certain answers. You should say something more about your thinking. Okay, I think this is for master's class, it's always good for students to have, more room to think about it. Not always just give you all the materials. Okay, I think for logical thinking is more important than just give you all this material. Okay, all right. Then maybe that's it. Okay, thank you very well.
Thank you.
So the third one will be Daisy. Okay, I go back to my irony and Daisy. Um, this one, right? Sanction. Sanction. Okay, so then I'll put it in the desk.
Hi everyone, this is my assignment. About from the eight answers from the equation we have in the book. Because it has two positive numbers here, we have 0.01 for the east and the second one is 0.59 for the top. And from here I divide into two situations that if I assume For the first one, if I assume that the easiness of the rating of the professors increase 1 unit, the rating of that professor will increase 0.01. In that situation, we hold in constant the half rating. And for the second one, if a professor half rating increase 1 unit, and the rating of the professor will increase 0.59, holding constant the estimate rating too. From Let's continue with the key answer. After we inputting the data into eView, we can have the result here the same with another two students. We have is value is here. Yes. The is value is 0.01 and the half is 0.59. The completion data is 7.23. And from the C answer, we have, in my point of view, I believe that the teaching rating of our officials depends on how hot and easy of the teachers is, because I think that most of us will feel comfortable if we can study with the professors. It's easy. And also we can consider about the hot of the professor. The hot here can be considered as the teaching skill or a special character of the professors. Not only to this variable, we can add another variable like the qualitative rating, just test how practical and useful of the knowledge of the professor and the experience of the professor. We can also consider about innovation rating. The innovation rating here is how can the professor use the technologies or the supporting teaching, such as the modern facility in school, and apply anything to the teaching. From the D answer, I think that hot will decrease because the hot value is only has two options for us to choose, that hot or not otherwise. Besides that, I believe is will increase because the value of is insignificant because it's very small. But I expected that if we add it to another coefficient, it will remain the same result because the variable will be independent and not impact to another two. That's all. Thank you.
Okay, any questions from you? Okay, Daisy, I'd like to ask you one question, okay? When you answered the part A, okay, do you see the answers? I mean, when you read the questions, we already know the result, which showed it on the problems, right? So we were easy to see the relationship between the is and hot is all positive sign, right? And I'm asking that this is what this course is really emphasized on, okay? We always say that before you estimate the equation, you need to thinking about the theoretical relationship between x and y variable first. Do not look at the result. Just thinking the relationship between x and y. Okay? But when we answer these questions, it's easy to affect by the results already provided in front of us. So we'll immediately see the positive relationship between those x variables with y. Then I'm asking that when you do this problem, do you really think that these two variables has positive relationship with the y? Or because you already see the result, you have seen the result, then, just affect your thinking, then you're thinking that, yeah, really, there's a positive relationship. This is what my question is.
If we cannot see the result first, we can, in our point of view, we can see in the reality life, and the heart and the rating of the teacher can be applied to this equation. I think so. Yes, we can guess that, and then we run the result here. Yes.
Okay, so from these questions, we do know that since we just have these two variables, then with all this data, then we run it, and it really shows the positive relationship. Okay, so far what we learned is look at the sign of the relationship between x and y. And this is the first step. Okay, before we run anything, before even we collect the data, after we set up the model, we need to think in theoretically the relationship between x and y first. Then after we have data, then we check whether the result is, match with our thinking or match our theoretical point of view. Okay, instead of just look at the result first and see the relationship between these x variables and y variables. I think this is just upside down. Okay? So you have to have your mind first that theoretical reason or foundation, fundamental relationship, fundamental theory is always important than the result. Okay, that's the way to do our regression analysis in practical, or even in your thesis. Understand what I'm saying here? So here, Daisy shows some of the important variables maybe we can think about, okay? Such as quality rating means that how practical or useful knowledge is provided by this course, okay, by this professor, or something like the technical skills, or this means teaching experience, right? Okay, and those innovations, like the professors can use high tech, something like that. Okay, I think this is all good slide to thinking about the variables, which is important nowadays to be the performance of a university professors. Okay, very good. Thank you very much. All right. All right, and let me just stop here for a while, since it's already about 10 o'clock. Okay, let's stop here for a while, then we'll come back 10:10. Okay, 10 after 10.